This section examines ignition. A basic ignition system consists of the battery, low tension cables, the ignition coil, distributor, coil high tension cable, spark plug cables, and spark plugs. The ignition system provides high-intensity sparks at the spark plugs to ignite the fuel charges in the combustion chambers. The sparks must be supplied at the right time, and they must have sufficient energy over a range of conditions to ignite the charges. The energy comes from the battery and alternator, and the voltage is increased by the ignition coil. The system has two circuits. The primary or low tension circuit initiates the spark. The secondary or high tension circuit produces the high voltage and distributes it to the spark plugs. There are three general types of ignition systems. Breaker ignition uses contact breaker points in the distributor to initiate the spark. Electronic ignition doesn't need contact points. When a signal is received, triggering occurs through transistors in an ignition module. Direct ignition has no distributor and uses coils to supply high voltage direct to the spark plugs.
Now, let's take a look at a conventional turn signal circuit to see how flasher operation is affected by a blown bulb.
As the wiring diagram shows, the turn signal indicator, side marker light, and turn signal bulbs are wired in parallel. With the bulbs wired in this way, total circuit resistance is less than the resistance of any individual bulb. This is known as equivalent resistance. When the turn signal switch is activated, the flasher begins cycling according to the amount of current flowing in the circuit. Under normal operating conditions, this is typically 60 to 120 times per second. In the case of a blown bulb, however, the equivalent resistance in the circuit will rise, resulting in reduced current flow. Under this condition, the flasher will either cycle considerably slower or stop cycling altogether. This can be demonstrated by removing one of the directional bulbs on this vehicle and then activating the turn signal. As you can see, the turn signal indicator is on steady.
Since the mid-90s, most manufacturers have been incorporating electronics into the turn signal circuit. When a bulb blows out on this type of system, the turn signal indicator will flash very rapidly, as you can see here.
Most vehicles use analog or needle-type dash gauges to relay information to the driver concerning items such as coolant temperature and fuel level. These electromagnetic devices rely on a variable resistance sending unit to regulate current flow in the gauge circuit.
A faulty sending unit is the most common cause of an inoperative or malfunctioning dash gauge. Before replacing a sending unit, however, to correct a gauge problem, perform this simple test.
Begin by turning the ignition key on. Next, disconnect the harness connector at the sending unit. With the sending unit unplugged, the needle should deflect all the way in one direction. Now install one end of a jumper wire into the harness connector and attach the opposite end to a good ground. Under this condition, the needle should make a full sweep in the opposite direction.
This test, which can also be used to check the operation of the other instruments, confirmed that the wiring and gauge are good. In this program, we've demonstrated some of the tasks you'll need to know in order to pass the ASE Electrical Electronic Systems test. Don't forget to consult your A6 Test Readiness book for additional content area and task list information. For Bergwall Productions, I'm Pete Bellotta. Thanks for watching, and good luck on test day.